Hi everyone, so hope you're all doing well today. So in this video today, we're going to answer this question 4 from the 2018 Edexcel not first year paper, proper A-level second year maths paper. It's the pure maths exam, the paper one at Edexcel exam. And it's this question 4, and it's kind of to do with numerical methods, this one. So it's about using iterative formulas to approximate solutions of equations. We're going to have a look at this question here today. But before we get into today's video, please do make sure you do click like and click subscribe. Click that like button, click subscribe. It really helps me out and it's free. It doesn't cost you anything and it takes you less than a second. So please do click those buttons and we'll get into today's video now. So we have a curve with the equation y equals 2 ln 8 minus x. And we've got this also other line here, this y equals x straight line, and they meet at the point x equals a. Okay, so we've got this point of intersection we can see on the graph there that they've sketched for us. So this point of intersection there, which is at a there. Okay, so the first part of the question says show that a is between 3 and 4, so we've got to show that a is between the number 3 and the number 4. I mean, we can see that it's less than 4 just by looking at the graph there, but we want to show that it's between 3 and 4. So the key thing to realize is that at this point of intersection, we know that this curve here, this y equals 2 ln 8 minus x, meets the y equals x straight line graph. So what that means is that at this coordinate a, so for part A of the question, at x equals a, we know that this 2 ln 8 minus x is going to be equal to x, since y equals x and y also equals 2 ln 8 minus x at this specific point there. Okay, so then it's just really a case of making this rearranging this equation so that we get an equal 0 on one side of the equation. And you'll see in a minute why we're going to do that. So we're going to get 2 ln 8 minus x and then minus x equals 0. So how does that help us answer the question? So, I mean, we formed an equation just with x involved, and we want to show that x is between 3 and 4. Well, we know that if we plug in the solution a into this equation, I mean, we don't need to, if you're doing this in the exam, you don't need to write what I'm about to write down. But I'm just going to explain why we're about to do what we're about to do. So at the points, at x equals a, we know that 2 ln 8 minus a minus a is equal to 0. So what I've done there is I've just substituted x equals a into this formula there. So we know that at that specific coordinate x equals a, we know that this is going to be true there. But we want to show that a is between 3 and 4. So what we're going to do, instead of substituting a into this formula, is we're going to substitute in x equals 3 and x equals 4. So we're going to sub x equals 3, make that look like a 3, and x equals 4 into 2 ln 8 minus x, take away x. I'm going to substitute those two numbers into this expression there. So why am I going to do that? Because if a is between 3 and 4, then it means that if we plug in x equals 3 and we plug in x equals 4 separately, we're going to get two numbers, obviously, and they must be different signs. Now, we know that because if we have a solution to this equation here, this equation there, when x equals a, that means that when we plug in a, we get 0, of course, right? So if we're going to plug in two numbers either side of a, so in this case 3 and 4, then when we plug in those two numbers, we're going to get different signs. Okay, so we're going to get a negative number and a positive number. So the reason for that is because, I mean, if we think about a graph, so let's say we sketch this graph y equals 2 ln 8 minus x. So I'm going to actually write this again just to explain this properly. So we're going to sketch the graph here, y equals 2 ln 8 minus x minus x. Now I've got no idea really what, well, I mean, if we thought about it, I guess we could have a go at sketching, but I've got no real idea what it looks like. So I'm just going to draw like a random curve like that. Okay, so we can see we've got a root here. So remember, a root is a point, an x value, whereby the y coordinate is 0. So we've got a root there, okay? And that is going to be our a. That's our a, okay? We know that's our a because when we substitute a into this formula, we get 0 because we need to get 0 because x equals a is our root. It's our solution. It's our point of intersection, right? So we need to get 0 when we get this new expression there, and when we plug in a, right? That should be obvious, hopefully. So when we plug in the number 3, right? When we plug in the number 3, what we see is that we get a positive number there. That's going to be a positive number. So when we substitute 3 into this formula, x equals 3, the graph's telling us we get a positive number. Now, I don't know, obviously, this is not the accurate graph for this equation. I'm just giving you a rough example. And then x equals 4, if we plug that in, we can see we get a negative number. That's a negative number. So what I'm trying to say to you guys is that when you're plugging, when you want to show that you have a solution between a number and another number, there must be a change of sign when you plug in the two numbers into your expression there. Now, I mean, again, this diagram there may not be accurate, could be the other way around, but there's got to be a change of sign. So remember, this is called the change of sign method. So change of sign. So you may have been taught that in class. So this is a change of sign method. Again, you don't need to do all this work for 2 marks. I'm just trying to explain to you guys in case any of you don't understand why we're doing what we're doing here. And it's really important in maths that you understand why you're doing what you're doing. Okay, so I'm going to take the formula and I'm going to plug in x equals 3 first. So we've got 2 ln 8 minus 3 take away 3. I'm just going to plug that into my calculator. We'll see what we get. So we got 2, let me go to the right mode. 2 times ln 5, I mean, that's ln 5 there, and then take away 3. Right, so we get 0.218. I'm going to round that to 9 to 4 significant figures. So this is positive. Okay, this is a positive number. So actually, yeah, this kind of graph there, even though this graph that I sketched here is not obviously not accurate, but it kind of is illustrating what's actually going on here. So when we plug in the number 3, we're getting this positive number here, which in this case is 0.2189. So when we plug in x equals 4, hopefully we get a negative number, because then that proves to us that we've got a change of sign. X equals 4. So we're going to plug that in. 2 ln 8 minus 4, take away 4. Let's see what that gives us on the calculator. 2 times ln 4, take away 4. Yeah, we get a negative number. Minus 1.227. Again, to 4 significant figures, which is less than 0. I mean, you don't have to give the numbers to a certain degree of accuracy. I just randomly chose 4 significant figures, but 3 is normally fine. Okay, so we've got 2 different numbers which are different signs. So therefore, since we have a change of sign, so we've got a change of sign between x equals 3 and x equals 4. So since we have a change of sign, so again, my handwriting is not looking very good. So since we have a change of sign, and you don't, I mean, again, because it's only a 2-mark question, you don't need to go into this detail, but this curve y equals 2 ln x minus, 8 minus x, sorry, my bad, 8 minus x, 8 minus x minus x is continuous. So this is a continuous curve. Again, you don't need to mention this. This is more stuff you would mention perhaps in a university exam, because again, it's only 2 marks here. You don't need to do the amount of work that I've done. But since it is a continuous curve, right, we've got 2 continuous curves, right, intersect each other, y equals x, and this curve there. So when you put the x equal to this there, again, you're going to get another continuous curve. So because we've got a continuous curve, we've got no discontinuities between 3 and 4, we can safely say that there's going to be a root between 3 and 4. So we know, since there's a change of sign, we know that there is a solution to the equation 2 ln 8 minus x minus x equals 0, or you can say 2 ln 8 minus x equal to x, which is the same, exactly the same equation between 3 and 4. So therefore, and the solution, by the way, is x equals a. That is our solution. That is the solution. So therefore, we know that a is trapped between 3 and 4. So I mean, in an exam answer, just to be really clear about this, all you would need to do is you would need to write that there. So put them equal to each other, then make them equal to 0. And then what you would do now is just sub in x equals 3, x equals 4. So you do this working that I've done that. And then a little sentence at the end to say we've got a change of sign. Since there's a change of sign, we know that a is between 3 and 4. So that's all you need to write. But again, in my videos, I like to go into detail to help you understand the maths that you're doing. Okay, so that's part A. So then part B. So now we've got, again, so we've got our figure showing the two curves there. So a student's going to use an iterative formula, this iteration here. Xm plus 1 is equal to 2 times ln 8 minus xm, where n is a natural number. Just as a reminder, remember our natural numbers 1, 2, 3, 4. It's just positive whole numbers. That's what natural numbers are. Some people include 0, but I mean, depends who you talk to. There's no definitive answer whether 0 is a natural number. Anyway, so yeah, this is used to find an approximation for a. And just a little comment, you know, as we can hopefully realize this, you know, the reason why they've chosen this approximation to approximate this solution here, this x equals a solution, is because obviously when you set x equal to this there, you get 2 ln 8 minus x equal to x. So what they're doing, and what the whole point of an iterative formula is to approximate a solution to an equation, the whole point of it is that you get a formula for x equal to some expression which is equivalent to setting this x equal to this there. Hopefully that kind of makes sense. So they're just generating, this is just a formula to generate a sequence of numbers which hopefully will approximate this there. But I think the question is going to ask us to work out whether we can use this in the first place. So right, so the question is saying that, yeah, we're going to use this iterative formula. So using the graph and starting at x1 equals 4, determine whether or not this iteration formula can be used to find an approximation of a, justifying your answer. So we've got to use the graph, and we're going to start at x equals 4. So hopefully if you've done some practice with these kind of diagrams, they're called cobweb and staircase diagrams. Hopefully you will have seen those kind of diagrams before. So what you do with a cobweb or staircase diagram depends what it looks like. So we'll have a go and see what it looks like. Is that you go up to your curves, you start at x equals 4, and you go up to your iterative curve. So when I say iterative curve, what I mean is the y equals this expression there. So you go up to your curved line, not your straight y equals x line. You go up to your curved line, and then what you do is you do a horizontal line over to your y equals x line. So you do a horizontal line over to that. So the reason why we do this is because we start, so our first number in our sequence we chose is x equals 4. So the idea is what you do is you plug in x equals 4 there. So you plug in x equals 4, you calculate 2 times ln 8 minus 4, you get a number. Now that number you get is actually going to be this. I'll do this in green. So this number there is the number that you get. So that's why you go across horizontally. And this number that you get down there, oh no, my pen's decided to freeze. So this number that you get down there, this green dash there, is the same as the y coordinate of what we get over there. Because remember that on this straight line y equals x, the x coordinates always equal the y coordinates. So therefore, what that means is that this green dash there, this x number there, is equal to this y value there, because we've got a straight line y equals x graph. So that x coordinate is equal to that y coordinate there. So this is going to be like our our x2 there. So this 4 is our x1 in the sequence. Our next number of the sequence is going to be this one there. So again, what we do is we go to our x2, so our next number of the sequence, and then we go up to the curve again. So we go up to our curve, and we get to this point there. Same process, we now draw a horizontal line to our straight line. And this y value there, so the y value we get there is the same as this x value there, because remember, y equals x means the y coordinate equals the x coordinate. So we get this value there, and I'll do this in green again. So this is going to be our x3, our third number in the sequence. So again, we continue with this pattern. We go down to the curve, horizontal along to the straight line, up to the curve, horizontal to the straight line, down to the curve, horizontal to the straight line. Hopefully you can now get the picture. We're converging. Okay, so if we keep on generating this sequence over and over again, we keep on plugging in the numbers into this iterative formula over and over again, the diagram clearly shows us that we're getting closer and closer and closer to the solution, the point of intersection, the A coordinate, the x equals A coordinate where they intersect. So what you would do for this one is you would do exactly what I've done there. So you draw in your dashed lines, okay? So you do exactly what I've done there. You don't have to label x1, x2, x3 like I've done here, but I personally probably would, just to be on the safe side in the exams. So just label, just show the examiner you know what you're doing, you know what the actual diagram, this in this case, this cobweb diagram, because we're kind of generating a cobweb here. So you just say, you just try and explain what's going on your diagram. And then down here, we'll just try and fit it in down here. So what you would say in your sentence is you would say, we can see from the cobweb diagram above, so from the cobweb diagram, I'll put this in speech marks, that the iteration, so the iteration converges, so it's converging to that solution, x equals A. So it's converging, converges, let me use proper English. So it's the iteration converges to x equals A. So therefore, we can use the iteration formula. We can use this iteration formula because it converges to the solution that we want. Now, sometimes some iteration formulas don't converge. So, I mean, you may get a diagram instead of doing like that there. So you may have like a curve there, another one there. You may get a diagram that just spirals out of control and diverges instead of converges. So it just depends on your diagram, depends on your starting point, depends on the curves you have. So therefore, yeah, it's always good to do these diagrams because then you can see, are you converging to that point of intersection or are you diverging? So that's the whole point of these diagrams. So yeah, any questions, do drop a comment and let me know, but hopefully that was good to go through an example of iterations and, approximating solutions to equations by using iterations. So I know it was only a 4-mark question, but I find a lot of students do find this topic quite a tricky one, quite a fiddly topic. So it's just good to go through how these kind of processes work. So thanks a lot for watching. If you are interested in having an online maths tutor for either A-level maths or GCSE maths, please do email me because I am available to help out. So my email is doctordifferentiation@gmail.com. So just drop me an email, just drop me some details about you, whether you're doing A-level maths, GCSE maths, and if there's any specific areas of maths that you need help with. So drop me an email or get your parents to drop me an email, and then we can discuss everything about price, etc. So drop me an email and we can get sessions booked in.